Week 2, lesson 3. Okay, so this one is about something called the cross product. It's also known as the vector product. There's a fairly detailed formula that you're looking at right here. Probably most important to recognize is that if you're given two vectors and you do the cross product, you end up with a third vector. Okay, so your result is a vector, not a number, and it's perpendicular to both of the originals. All right, now, again, you guys are kind of lucky as far as this whole COVID thing, because you'll have this formula in front of you, right? You can write it down and use it on whatever. Prior years have had to memorize this formula. So, in fact, I do it kind of differently. I don't really like this formula. In fact, what I do instead is I derive it, or I use expansion by minors in order to do it. So let me show you how that works. If I set this matrix up with an I, a J, and a K. And then I put vector A in the next row, A sub 1, A sub 2, A sub 3. And I put vector B in the bottom row. And then I do expansion by minors, all right? Now, those of you that had me for Algebra 2 Honors, we did expansion by minors. And I'm going to expand about this row. So it's going to be I minus J plus K. If you didn't have me for Algebra 2, you may have to actually look up how to do expansion by minors, or just sort of write down this formula and use the formula. Okay, so if I'm doing expansion by minors, I'm going to, and I'm looking at the I term, I'm going to eliminate this column and this row and do down minus up, if you remember that. Oh no, it's not going to let me erase the whole line. Well, okay, I guess I won't be drawing in the lines on the next ones because it makes it way, way, way too hard to read. Sorry about that. I thought I could erase my whole drawing, but I guess not. Okay, so then J, eliminate that row and that column, and I get A1B3 minus B1A3. Okay. And then if you're looking up here going, wait, that doesn't look right, don't forget there's a negative out here that you need to distribute. And then K, eliminating that row and that column, I have A1B2 minus B1A2. All right, so again, you can check. You'll see that this is what you get for the X coordinate, this is what you get for the Y coordinate, and this is what you get for the Z coordinate. Okay, so scooting this up, and it says find the cross product. Now again, some of you might be using the formula. I am going to do this by expansion by minors. So let me set up my I, my J, my K. The first vector coordinates are going to go here, 2, 3, negative 1. And these coordinates are going to go in the next row, 4, negative 1, 1. And then, that should be a minus, sorry about that, minus J plus K. Okay, so on the I coordinate, it's going to be 3 times 1 minus negative 1 times negative 1. For the J coordinate, again, eliminating the row and the column, it's 2 minus negative 4. And for the K, it ends up being negative 2 minus 12. All right, so my vector, I'm going to put this in a column vector, is going to be 2, 6, oh, don't forget the negative right here, negative 6, and negative 14. Okay, now, a couple cool things. The magnitude of that cross product, right? So if you actually take the magnitude of that vector, you find the area of the parallelogram encased by the vectors. In other words, let's just say in 2 dimensions that I had this vector and this vector. If I was able to do the cross product on that, right, which I can, I would end up with the area of this parallelogram. That's what I'd end up with. Okay, so we're going to try that here with these 2 3-dimensional vectors. So first, I need to figure out the cross product. 3, negative 2, 1 for vector A, and 1, 1, negative 5 for vector B. I, J, K. Let me erase some of this. Okay, so for vector I, it ends up being 10 minus 1. For J, it's negative 15 minus 1. And for K, it's 3 plus 2. So my cross product, right, which is a brand new vector, is 9, 16, 5. And then I just have to find the magnitude of it. The magnitude, which is going to be the square root of 9 squared plus 16 squared plus 5 squared. Feel free to break out a calculator and do that calculation to 3 significant digits. It should be 19.0. All right, now this last blue box down here, if you're asked to find the area of a triangle, just keep in mind it's half the area of the corresponding parallelogram. I'm not doing an example of this for you in the notes, but you definitely will need this for the worksheet.